Time varying acceleration 1. An object's velocity is measured to be Vx as a function of time is alpha minus beta t square, where alpha is 4.00 meters per second and beta is 2.00 meters per second cube. At t is equal to 0, the object is at x equals 0. A. Calculate the object's position and acceleration as functions of time. B. What is the object's maximum positive displacement from the origin? So let's start with part A. The velocity Vx as a function of time t is the rate of change of its position dx dt, which is alpha minus beta t square. So I can calculate delta x, the change in position, integral from 0 to t, Vx dt, which is the integral from 0 to t, alpha minus beta t square dt. So the change in position is x at time t minus x at time 0, which is 0. We obtain from the integral alpha t minus beta divided by 3 t cube. So x0 is 0. So I obtain the position as a function of time, x of t, to be alpha t minus beta t cube over 3, which is, since alpha is 4.00 t minus beta was 2.00 t cube divided by 3. So that would be the answer to position as a function of time. So I should note that this is position in meters and the time t is in seconds. So we're using SI units. For the acceleration ax of t, I need to take the derivative of velocity with respect to time, dv dt. This is the derivative of alpha minus beta t squared. Since alpha is a constant, its derivative is 0. I obtain minus 2 beta t, and by substituting for beta 2, ax as a function of time t is minus 4t, where this answer is in meters per second square. So this is in meters per second square. So what is the object's maximum positive displacement from the origin? That is part B. So at maximum displacement delta x maximum, I will have the rate of change of position dx dt, which is Vx equal to 0. So since Vx was alpha minus beta t squared equals to 0, so at that particular time t prime, this is what's going to happen, and that time t prime is square root alpha divided by beta. So the maximum displacement, delta x maximum, is by substituting this to alpha t minus beta t cube over 3 for the displacement as a function of time, I obtain alpha square root alpha over beta minus beta over 3 alpha over beta to the power 3 over 2. So substituting for alpha 4 square root 4 over 2, and beta is 2 minus 2 over 3, 4 over 2 to the power 3 over 2, we obtain 4 square root 2 minus 2 over 3, 2 to the power 3 over 2, and we find that delta x maximum will be equal to 3.77 meters when it is reduced to three significant figures. Okay, so we had a velocity as a function of time, alpha minus beta t squared. When I take its derivative, I obtain acceleration as a function of time. So I have a time varying acceleration minus 4t. And the position is just integral of velocity with respect to time. From time t equals 0 to time t, I obtain position as a function of time, alpha t minus beta t cubed over 3. Then I substitute for alpha 4 and beta 2. And for the maximum displacement from the origin, I would obtain the extremum point in the position as a function of time by calculating its derivative with respect to time, setting it equal to 0. This means when the velocity is 0, I obtain this. So velocity is alpha minus beta t squared. At this particular time t prime, I obtain 0 velocity. So that particular time t prime is square root alpha over beta, which I substitute into delta x as a function of time here. And that gives me 3.77 meters as my final answer.